All right, so let's get started with the logarithm unit test. So the first question we have, after the closing of the mill, the town of, okay, whatever the town, experienced a decline in its population. The ratio between the elapsed time t in years since the closing of the mill and the town's population. Okay, a function is modeled by the following function. In how many years will this town's population be 9,000? Round your answer if necessary to the nearest 100, which is two decimal places. So we want to find the value of t, for which we have 9,000 of population. So we want to insert this 9,000 here and find the value of t. So that means we want to find 9,000 equals 9,000 equals 12,000 multiplied by 2 to the power negative t by 15 multiplied by 2 to the power negative t by 15. So I'm replacing t with x, and I can find the value of t from here. So since they have asked me to give my answer in two decimal places, I can write this thing as whoa. So this thing is 6.23 when I round this up. So 6.23 should be my answer. 6.23, because I'm rounding out to two decimal places. There we go. Evaluate the logarithm. Round your answers to the nearest thousand. Okay, now we need in three decimal places. Nearest thousand. 3 dp. Three decimal places. So I have to evaluate this thing. So we have logarithms. Okay, so we don't have the customized log operation here. That's okay. So what we can do is, we know that we can write this thing as log base 10. So we write logarithms of base 10 as lg. We can write this as lg lg 1 by 50 divided by lg2, and this will give us the same answer as this. So this is what I'm going to write. So L log 1 by 50, this thing is divided by log of 2. Okay, that gives me negative 5.643. Negative 5.64. Okay, when I round up to 1000, so 644. And this is the same as log base 2 argument 1 upon 50. So let's check it out. Log base 2 argument 1 by 50. Negative 5.644. Yes. Negative 5.644. Negative 5.644. Here the following in the form log c. So they want us to rewrite this thing in a single log. So when we add logarithms with the same base, both of them have 10, we multiply the arguments. 4 times 3 is 12, so I can write log of 12. What is the solution of the equation? Round your answer if necessary to the nearest thousandth, again to three decimal place. 3 dp. Okay, again, when they ask us to find the solution, we make t the subject here, so that means 3 to the power 5t by 4 equals 80 because we're dividing both sides with 10. Now we introduce both sides logarithms of base 3. So 5t by 4 equals log 3 base argument 80. So t equals 4/5 of log 3 base argument 80. So let's write down 4/5 log base 3 argument we have 80. 3.191. 3.191. Consider the equation, this thing. Solve equation for t. Express the solution as a logarithm in base e. Okay. And approximate the value of t around your answer to the nearest thousand. Okay. So this thing, we need to we write e to the power 0.25t equals 9 by 6. Now we want to introduce logarithms of base e to both sides, so 0.25t equals log base e, that is ln to 9 by 6. So t equals ln 9 by 6 over 0.25. So ln 9 by 6 over 0.25. And now we'll just have to evaluate this. So that is 1.62 nearest thousand, 3 decimal place, 1.622. 1.622. Which of the following is equivalent to this thing? All right. So let's see. We have logs. This one is base 10. This one is base 8. So we can rewrite the denominator as log to base t divided by log to base 8. Okay, we can write this like this. And now we have log t multiplied by log 8 over log t. So they get cancelled out. We only have log 8 here. All right, table 1 contains outputs of the function. Fx equals to b to the power x for some values, x values, and table 2 contains outputs of the function gx equals to log base b argument x for some x values. In both functions, b is the same positive constant. Okay, fine. Fill in the missing values in the table if necessary around your answers to 3 decimal places. You do not need a calculator. All right. So what is the... Okay. So basically they're the reverse, not reverse, inverse of each other. So if b to the power x is something like this, then log base b argument x will be something like this. So which means the x and y values will be swapped. So here, when we have -1, we have 0.5. So 0.5 -1. When we have 3, we have 1.585. So for 3, we should have 1.585. And when we have 2.585, we have 6. So that means this is also 6. All right, we have to evaluate this thing. So we can write 81 as power of 3. So that means 3 to the power 9, I guess. No. 3 to the power 4. Sorry, not 42. 3 to the power 4. Yeah, 3 to the power 4. So log base of 1/3, 3 to the power 4. We can bring it here, 4 multiplied by log 1/3 and argument 3. Now what we can do is we can flip um, the base and the argument, so this becomes log base 3. Now we can write 1 up 1/3 as 3 to the power minus 1. I can bring this minus 1 and 1 here, so 4 into 1 by minus 1. This thing becomes 1, so the answer is negative 4. Alright, last two questions left. Consider the equation. This thing, solve the equation for x express the solution as logarithm base e. So e to the power negative 7x equals 12 by 5. Introducing ln on both sides, we have negative 7x equals ln of 12 by 5. So x equals ln 12 by 5. Oh no, x equals ln 12 by 5. X equals ln 12 by 5 divided by negative 7. So this thing is going to be divided by negative 7. Okay, I make the subject here. So ln of 12 by 5 divided by negative 7. Now we have to approximate the value of x to the nearest 1,000, 3 decimal places. Let's figure this out. Negative 0.1252, 3 decimal places. Okay, nearest 1,000. Right. We have the following in the form log₂. Again, they want us to write this thing as a single logarithm. When we subtract two logarithms, we divide their arguments. So 10 divided by 2 is 5. So we write log 5. That's it. We're done.